What's up, everybody? This is Mr. Tui, founder of mtcollegeprep.com. And if you're looking for an ACT math review, you're in the right place. In this video, I'm going to teach you how to solve a variety of ACT math questions from an official released ACT math practice test. And I'll be solving all the questions using my unique and powerful test-taking strategies that simplify the questions. If you like this video, make sure to like it. Also subscribe to my channel and look out for any future updates and more ACT math review videos coming out. In the meantime, sit back, relax, and enjoy this ACT math review. All right, welcome everybody to ACT Math Prep with Mr. Tui. I've got a student with us, Abby. Say hello to everybody, Abby.
Hello.
All right, thanks, Abby. Really appreciate that. We got some questions up on the screen. We're going to jump into these here on this ACT practice test. But first, I want to actually go to the rules for ACT Math. You've got that document in front of you, Abby?
Yes, sir.
Okay, great. Let's go to that. And I just want to read rule number 1 and 2. This is kind of what we're going to be focusing on today, along with some of the more specific concepts in the course. But I want to give you my first 2 rules. We're going to discuss these, and we're going to jump into the questions. Go ahead and read rule number 1, please.
Oh, me?
Yep.
Okay. Number 1 is avoid algebra whenever possible. Instead, plug in values for the variables and solve.
Yeah, I would argue there's only a handful of questions, maybe like, I don't know, 5 or 6 on every ACT that actually require a specific sort of step-by-step algebraic operation, you know, like isolating a variable or something like that. The vast majority of questions that have variables in them and look like they're algebra questions, you can actually solve by plugging in values for the variables. We're going to practice that strategy a little bit on the questions today, so I want you to kind of be aware of that. I'll be referencing that rule quite a bit. Go and read the second rule for us, please.
Eliminate incorrect answers, choices using basic logic. For word problems, remember that you're dealing with real-world problems and real-world solutions.
Yeah, there's a lot of questions on the ACT where you can eliminate most of the incorrect answers and sometimes even just find the right answers just using basic logic without doing a math thing. All of the answers are going to have to work in the real world. So if a value just looks too big or just doesn't seem like it makes sense, it probably is too big. Or if a value feels way too small, it probably is too small. So we're going to practice using a lot of just basic logic kind of all throughout the test. So we're going to practice these 2 strategies a bit today on the questions. There's also some more specific concepts that you just have to know for the ACT. You've just got to know, like probability. I think we have a probability right off the bat here on this problem set. You just have to know like mean, median, and mode. You just have to know sort of what a ratio is. You have to know what functions are. So we're going to go over some of those specific concepts as well. Let's start with the first question I have up here on the screen. This is from an official ACT practice test. Go ahead and read question number 1, and we'll discuss this one together.
The blood types of 150 people were determined for a study as shown in the figure below.
All right, and then go ahead and read the rest of the question.
If one person from the study is randomly selected, what is the probability that this person has either type A or type AB blood?
Okay. Is it pretty clear, Abby, this is a probability question?
Yes.
Yeah, right? I mean, the thing we're solving for is always sort of at the end of the question. That's the case here. What is the probability that this person has either type A or type AB blood? That's what we're solving for here. Let's talk about probability just in general first and get a handle on that concept. Are you familiar with probability? Have you solved some probability questions before? Not. Okay. Let's talk about it real quick. I'm going to give you an example of a probability question using a 6-sided die. A 6-sided die. Okay? If I said, Abby, what's the probability of rolling a 3 on a 6-sided die? The probability of rolling a 3. Do you have any idea how to solve that?
I have absolutely no idea.
No problem. Okay, let's go to it in the rules real quick. So this is, let's see, basic concept A. Basic concept A on the cheat sheet right below the rules. Do you see basic concept A? It says probability and odds, okay? And I want you to read that first bullet point for me, please.
Probability equals winners. Total number of possible outcomes.
Yes, that's like a division sign right there. So it's winners divided by the total number of possible outcomes, okay? That's sort of the formula for probability. I'm going to put that up here on the whiteboard as well, make that really clear. So probability is the winners or the winning outcomes that you're looking for. So probability equals the winners divided by the total number of possible outcomes.
Okay.
Okay. I'm going to explain what that means here with this example of the dice. Apologize for the really horrible handwriting. It's bad. All right. So let's start with that dice example. So if you have a 6-sided die, Okay? Six-sided die. How many possible outcomes are there when you roll a six-sided die?
6.
There's 6 possible outcomes, right? So that's your denominator with probability and six-sided die. There's only 6 outcomes when you're rolling it once. Does that make sense?
Yes.
All right, so you've got 6 possible outcomes, and then I think I said, what's the probability of rolling a 3 on a six-sided die? How many winning outcomes are there if you're looking for a 3 on a six-sided die? How many winning outcomes? I mean, really, another question is how many 3s are there on a six-sided die?
Okay, 3.
Yeah, there's not 3 3s on a six-sided die.
No, there's 2 3s.
Are you sure about that?
No.
I'm pretty sure there's 1 1, 1 2, 1 3, 1 4.
1 4. Yes.
1 5,
okay.
1 6. Right?
Okay, yes, I don't think I understood the question.
Yeah. Okay. Does it make sense now?
A little bit, yes.
Well, I mean, do you understand why there's 1 3 on a six-sided die?
Because there's six of them, so there's 1 of each.
Yeah, there's 1 of each between 1 and 6.
Yes.
Make sense? Okay.
Yes.
So there's 1 3. That's 1 winning outcome. So the probability of rolling a 3 on a six-sided die is 1 out of 6. Does that make sense?
Yes.
Okay. Let me give you another example. What's the probability of rolling a 2 or a 3 on a six-sided die? A 2 or
Would
a
that
3.
be 2 of 6?
2 out of 6. Exactly, right? Because now there's 1 2 and 1 3, but that's 2 winning outcomes. So that gives you 2 out of 6.
Okay.
What's the probability of rolling a 1, a 2, or a 3, Abby, on a six-sided die?
3 of 6.
3 out of 6. That's good. What's the probability of rolling a 1, a 2, a 3, a 4, a 5, or a 6 on a six-sided die?
That would be 6 out of 6.
6 out of 6 or just 1, right? Or 100%. It's the exact same thing, right? I mean, you're going to roll one of those 6 outcomes, on a six-sided die. There's no way around it. So really, you can't get anything bigger than 1 for probability. 1 means it's going to happen. 1 is the same as 100%. It's going to happen. Here's another question. What's the probability of rolling a 7 on a six-sided die?
0.
0, right? 0 out of 6, which is just 0 or 0%.
Okay.
Because there's no 7s. It's not going to happen. So probability is always between 0 and 1. Always.
0.
You can't have more than 100% probability. Just not happening. Does that make sense?
Yes.
You can express probability as a fraction. You can express it as a decimal. You can express it as a percent. It's all kind of the same. We might see some more of those questions a little bit later as we kind of work our way through the series. But right here, we're going to need a fraction form of probability. So with probability, I coach students always start with the total number of possible outcomes. That's the easiest place to start. What's the pool of possibilities you're drawing from? So on a six-sided die, right, there's just 6 possibilities, so just shove that into the denominator. It's a good place to start, okay? Let's reread this question here, okay? Let's read just the second half. Read it for me again one more time. We'll try to figure out the total number of possible outcomes here.
Sorry.
You're good.
Okay, you said the second part?
Yeah, it says if one person from the study.
Oh, okay. If one person from the study is randomly selected, what is the probability that this person has type A or type AB blood?
Okay. What's the total number of possible outcomes here in this scenario? What's the pool of people that we're drawing from? Do you have any idea?
70.
Right? It says if one person from the study is randomly selected.
Okay, so one person.
Well, we're selecting 1. Okay, that's true. But if one person from the study is randomly selected, so that's the total number of possible outcomes is one person from the study. Well, how many people are in the study?
150. Oh my gosh.
150, right? Yeah, that's our denominator, right? That's our total number of possible outcomes. Does that make sense?
Okay. Yes, it does. I had it cut off, so I wasn't even reading that.
Gotcha. Okay. All right, so there's our denominator. And then the question is saying, okay, what's the probability that this one person we select has either type A or type AB blood? Those are our winning outcomes. The outcomes we're looking for is that this person has type A or type AB blood. So we're going to put that in our numerator. The question is, well, how many people have type A or type AB blood? And you're going to have to use the graph here.
67, yes. 67 and 6.
Yeah, right? So 67 have type A, 6 have type AB. So how many people have either A or AB blood?
73.
73, and we just put that in the numerator, and there's our answer.
Oh, okay.
Okay. Does that make some sense?
Yes, that does.
Okay. So I always ask yourself that question first. Okay, what's the pool that we're drawing from? How many people are we drawing from?
150.
Yeah, exactly, right. And put that in the denominator, and then find out how, what the winning outcomes are, and then just put that in the numerator, and you've got the probability. But notice that our answer here is between 0 and 1, right? It's got to be for probability. So if you get something that's not between 0 and 1, you probably know you're not on the right track, or you're not quite thinking in the right terms. Any questions about that question?
I don't think so.
Okay. Yep. Answer choice D there, and we'll see some more probability coming up, at some point as we kind of work our way through these questions. So let's do the next question. I think this question coming up here involves mean. Yes. Do you know what mean means? Have you seen that before? As in like mean, median, and mode?
I have not.
No. Okay. Go ahead and read this question for me. We'll discuss that here.
Okay. Question number 2 is the monthly fees for single rooms at 5 colleges are $375, $310, $380, $340, and $310 respectively. What is the mean of these monthly fees?
Yeah, here you just got to know the definition of that term mean, right? You just
okay. What is the mean of these? Oh, I've heard of it.
You've heard of it at some point. Let's go to the rules real quick, actually. I've got this here. Let me see. It's on basic concept B. And it's the second bullet point. I've got mean, median, mode, and range all defined, and these pop up pretty frequently in the ACT. Go ahead and read read that first bullet point for me, please. We're going to talk about all these.
Mean divided by classic average. I'm supposed to say divided, correct?
Yeah, equals.
Equals classic average. Median equals middle number. Mode equals most frequently occurring number. And range equals difference between highest and lowest number.
Have you seen some of those terms before, Abby, or are those like brand new for you?
I think I've seen. I'm gonna say no.
Okay, yeah.
I'm not confident.
Yeah, I got you. Yes. So we'll start with mean. That's kind of the most common one. Mean is just classic average, right? And I think you've solved for averages before,
yes,
right? You know, an average. That's all mean means. It's just a fancy word for average. So really, you could reread this question as, what is the average of these monthly fees? Does that make some sense?
Okay. Yes, it does.
Yeah. So there's other types of averages. There's the median, which would be like if you arrange it from the lowest to highest, that would be the middle number, just like the median is the middle of a road, right? Do you drive, Abby? Do you drive yet?
I am learning.
You're learning, okay, right? But you've heard that term, right? The median, like don't run into the median, right?
Yes.
That's the middle of the road. It separates both lanes, right? So median is just the middle number in a set of terms. The mode is the most frequently occurring number. If that pops up like 2 or 3 times and the other ones just pop up once, then it's the one that occurs most frequently. That's the mode. And then sometimes they'll ask about the range also. That's the difference between the highest and lowest numbers. But here, all we need to worry about, Abby, is just the classic average.
Classic average.
Yeah.
Okay.
Do you know how to find the average in a set of numbers?
I can sure try.
Okay, let's do it together. I'll guide you through it. So, when you're finding average, all you got to do is add up all the values and then divide by the number of values.
Yes.
And that's it. And that'll give you the average every time. So we've got 5 values here, right? We got 370, 310, 380, 340, and 310. So you want to find the mean, right? Classic average. Just add up those values. And you can use your calculator. The nice thing about the ACT is that, like, you've got the calculator, your calculator all the way through this math section. On the SAT, you've got a whole, like, non-calculator. You can use your calculator all throughout this. So bust out that calculator. You've got an iPhone nearby, right? You've got a phone nearby.
I added it all in.
Yeah, great. Okay, so add those up. What did you get, by the way, when you add all those up?
1,710.
1,710. That sounds about right. And then just divide by the number of values. How many values do we have here?
5.
We've got 5 of them, so just divide by 5. And what's that give you?
342. Is that right?
Yeah. What's the answer?
So it'd be $342.
Yeah, there. Answer choice H. That's it.
There we go.
That's not bad, right?
All right.
And I'll bet you knew. I mean, if it said average, I'll bet you could have answered that, right?
Yeah, it wouldn't have taken so much to process.
Yeah. So, I mean, a lot of this test is just like kind of knowing what things mean,
Okay, it's like the terms.
Exactly, right? Exactly. So you got to know that. And I do have I've got a glossary at the end of my rules as well. I might have mean on there. It's been a while since I've I've worked on this here. Let me see. Yeah, mean is there. Actually, go scroll down to the end of that rules document that you have.
I have it.
Yeah, and if you see a term that you don't know, well, look it up in the glossary. There's a good chance I've got it there. Mean is there as well. So are the others. Yeah, and I might be adding to that a little bit, kind of as we work our way through the series. But there's your definition there. Classic average. Okay.
All right. Thank you.
All right. My pleasure. All right. Let's do the next one here.
So I can go back when we're not having tutoring, and I can practice all the terms.
Oh, absolutely. Yeah. Use this as you're doing, any prep on your own or going through practice tests. You can use this document.
Okay.
Reference it. Yeah. All right. Go ahead and read question number 3 for us, please.
Question number 3 is, on a particular road map, half an inch represents 18 miles. About how many miles apart are two towns that are 2.5 inches apart on this map?
Ooh. What are we solving for here, Abby?
Okay, so on a particular road map. Sorry, I was trying to make
it clear. I mean, there's one thing is like reading it right and just like decoding the language. The other thing is like understanding it, right? Yeah, I coach students actually. If you read a question, you don't understand it, just slow down and reread it again. So that's totally cool.
Okay.
Yeah.
Okay. On a particular road map, half an inch represents 18 miles. About how many miles are two towns that are 2.5 inches apart? Okay.
Okay. So what are we solving for?
Gotta think about this. So, would it be 3 times 18? I mean, I know we got to.
Don't worry about what we're doing right now. Let's just figure out what we're solving for, right? There's a difference there.
Okay.
Right?
Yes. Okay. So we're solving for how many miles apart are two towns.
There you go. Yeah. And the thing you're solving for is always at the end of these questions, right? You're gonna see tons of word problems on the ACT. Really focus in on that last part of the question and be really clear, And then, and there's a difference. It's so funny, right? Because a lot of students, they see numbers and they're like, oh, I'll just multiply those two numbers. I'll just divide those two numbers. It's like, it's not about doing things on this test. Mm-hmm. It's really not. It's just about understanding what things mean. And then once you understand what things mean, you can figure it out. Sometimes that involves doing a math operation, but sometimes it doesn't. In fact, I don't even think we need to do a complex math operation here, if we really understand what the question's asking, what things mean here. Okay. So we're trying to figure out how many miles apart these two towns are that are 2.5 inches apart on the map. I want to start by drawing a picture, Abby. I want to draw a picture of this. Okay. So I'm just going to start here on just a clear spot on the whiteboard. So it says that 1/2 inch represents 18 miles. So I'm going to draw half an inch. I'll try to make it something like half an inch. I know it's not going to be perfect here, but something like half an inch. And so that's 1/2 inch. And that represents 18 miles. Okay, we just want to make this as concrete as possible. This kind of goes to that second rule of like using a lot of basic logic here to find the answers. Yes. Okay, and the question is, how many miles apart are two towns that are 2.5 inches apart on the map? Well, could you show me what 2.5 inches would look like if this is what half an inch looks like? What's 2.5 inches look like?
Do you want me to draw?
Yeah, I want you to draw. I want you to figure that out. Okay. What's 2.5 inches look like? Yeah.
That would be one hole. That would be 1.5.
Yeah.
2.
I'm just going to label this a little bit. Yeah.
Okay. Is that right?
Yeah, absolutely. There's 2.5 or 2.5 inches right there.
Okay.
Absolutely. Okay. Well, we don't even need to do a math thing here. I mean, nothing too complicated, right? I think you could probably figure out how many miles then, if half an inch is 18 miles, you probably figure out how many miles 2.5 inches is now.
Mm-hmm.
Right? If you were going to guess, just look at the answer choices. If you're going to guess what the right answer is, what would you guess?
I guess it would be 22.5. No, I was just thinking in halves. Okay. Yeah. It would be 18 times. So if I was just looking at it, I would say 90.
Probably 90. You'd be right. It's 90.
All right.
Right? And think about it here, right? Because each of these half inches represent 18 miles. So it's 18 plus 18 plus 18 plus 18 miles. Right? Or just 18 times 5. I think I heard you say that.
Okay, I thought it was 5.
Yeah, yeah. But does it make sense why you'd multiply 18 times 5 to get that?
It does.
Yeah.
Yes. I like the visual learning with the...
Yeah, if you can draw a picture on a word problem, I strongly recommend it. Start there. Because you've got to, the real work here, Abby, you've got to conceptualize the question the right way first. You got to think about it the right way first. And then once you're thinking about the right way, the right thing to do is just much more obvious. Does that make sense?
Yes, I think it does.
Yeah, good. So start there. And I think when going back to what you said right after that, you're like, oh, I think it's just 2 times 18. I think is what you said initially, right? Would you give you answer choice C? Numbers. I don't recommend number slapping on this test.
Yeah.
That's why you see 2 numbers, and I'll just do something with those numbers. But it's like, now step back, think about what the question means. If it's a word problem, you can draw a picture, and you're much more likely to be on the right track. Any questions about that?
I don't think so.
Great job figuring that one out. All right. Let's keep rolling here. All right. We're just going one question at a time. Go ahead and read question number 4 when you see that up on the screen.
All right. Given F equals CD which would be...
to the third power. Q. You could say cubed as well. It doesn't really matter. Yeah.
F equals 450 and D equals 10. What is C?
Ooh, what are we solving for here, Abby?
All right, we are solving for C.
We're solving for C. Absolutely. Okay. We can do some algebra here. It's not too bad. We'll probably talk about it.
Okay.
But where should you start on a question like this? We're trying to solve for C, but they give us these other 2 values. Where can we start at the very least? Where can we start?
Would be to insert the F and the D.
Absolutely. Plug those values in. I mean, let's start there. And this kind of goes back to that first rule, right? Like, don't worry about doing algebraic operations. Let's just think in terms of values to start. So plug in a 450 for F and plug in a 10 for D. Let's start there. Let me see you work this out. Beautiful.
Man, this makes me want an iPad.
It's handy with the iPad, let me tell you. I know I should probably upgrade to the Apple Pencil. I haven't. But,
it works.
But the iPad.
We don't know C, so then it would be... Would we just do X, or would we put C?
Well, call it C, yeah. C. I mean, some students are more comfortable, solving for X or Y, but I mean, it works the same way here. Yeah.
C 10. Oh my goodness.
Yeah.
To the third.
And that's perfect. I would probably use parentheses here.
Okay.
To make it really clear that it's C times 10 to the third power.
Okay.
What you had would work. I mean, C times 10 is the same as 10C.
Yes.
But when you're plugging in values, I think parentheses, or when you're dealing with multiplication, I think parentheses just make the relationship more clear. So.
Okay.
Do you understand what this part means here when we say 10 is being raised to the third power?
I do. Yes.
Yeah. So what is 10 to the power of 3?
10 times 10 times 10.
Yeah, and if you want to use your calculator, you can do 10 times 10 times 10, or you can do 10 to the power of 3 if you know how to punch that in. But what's 10 to the power of 3?
300. Or wait.
Ooh.
No. That's not right. That's not right.
Good catch.
That would be 1,000.
Punch it into the calculator. Yeah. What did you get?
I got 1,000.
1,000, absolutely. Yeah. So we could rewrite this. We could do 450 equals C times 1,000. And you're absolutely right. Anything raised to, if it's raised to the power of 3, it means that number times itself 3 times. Or if it's raised to the power of 2, it means that number times itself.
I try to figure that out in my head
twice.
before I do the problem.
Yeah, no, use that calculator. You can use it all throughout the ACT. Okay. Well, here we can do an algebra thing here. It's really not too bad to solve for C. Mm-hmm. Right? Do you know how to solve for C?
Okay. So...
And if you don't know, you can say no.
Okay, I'll say no so you can explain it.
Okay, no problem. Yeah. Let's step back. There's another way we can solve this by just using logic and common sense here. Okay? We're multiplying 1,000 times some number.
Yeah.
Okay? I got a question for you. What's 1,000 times 1?
1,000.
1,000. 1,000. But here we're multiplying 1,000 times some number, and we're getting something less than 1,000.
Okay.
We're getting 450. Yep. So C has to be less than 1, doesn't it?
It does.
It does. Look at the answer choices. You can tell me what the answer is without doing a math thing.
Okay.
What's the right answer here?
It would be F.
It's got to be F, and it is. Okay? It is.
My goodness.
All right. Right? Even if you look at I don't know what to do here, and some students don't, right? I work with them all the time. That's okay. Some students maybe I subtract 1,000 here, something like that. Maybe I divide. I'm not quite sure, right? And then you just hope you got it right,
Yes.
But if you just think about what this means and think in terms of the values, you can kind of figure it out. Let's talk about the algebraic operation here. So notice we're trying to isolate C. We're trying to get C alone.
Yep.
Notice C is being multiplied by 1,000. Okay.
Yep. So you want to divide.
So to get C alone, just do the opposite of multiplying by 1,000. What's the opposite of multiplying by 1,000?
Division.
Dividing by 1,000.
Divide.
Yeah, exactly. So it's 450 divided by 1,000. Punch that in your calculator real quick. I just want to confirm this and make sure we're on the right track. I feel pretty good about it. But what's 450 divided by 1,000?
It would be 0.45.
0.45 equals C. Any questions about that, Abby?
No, sir. I think I got it.
Good. Now, again, with a little practice, the algebra is much easier. But if you find yourself kind of stuck with like, oh, I'm not quite sure how to approach this question algebraically, step back. Think about what things mean in the equation.
Yep.
We've been talking about that quite a bit. But even with an equation, that means something. It's not just definitions here. It means there's some unknown number times 1,000 that gives you 450. And like, oh, it's got to be less than 1.
It has to be smaller.
So it's got to be small, and what's got to be F. Any questions about that, Abby?
Nope.
Okay, great. Let's keep rolling. Ooh, we got functions here. Functions. All right. Go and read question number 5 for us, please.
Okay. If f times x equals 3x plus 7 to the second power, which would be squared, then f times 1 equals what?
So I'm gonna stop real quick. So this right here does not actually mean f times x. It doesn't mean f times x. You've seen this stuff. This is function notation. And don't get me wrong, we were just talking about this, right? Oh, parentheses mean multiplication. So any confusion is more than understandable. But I want you to be aware of this. This is called function notation. Function notation. You've seen this before at some point, right? Like f of x equals something, g of x equals something, p of x equals something. You've seen that before, right? Have you? Right? You've taken algebra 1 or 2 previously.
Algebra 1 and 2. Yes, yeah. I have not finished.
Gotcha.
My algebra.
Yeah, you've probably seen it before though. Okay, right?
I am sure I have.
Yeah. So that's called function notation. So I'd read that as f of x. Okay. Before we solve this one, let's talk about functions kind of just in general. And I'm going to give you an example of a function just to the right of this question. It's a simple function, but we'll say f of x equals 2x plus 1. Okay. It's just a simple function there. And if I said, Abby, what is f of 3? F of 3. Do you have any idea what that means? What's that?
Is that 2x plus 1 after the first?
Well, yeah, I mean, this is the function here. But do you know what to do?
Yeah, I'm trying to write it down.
Oh, yeah. If you need to pan over to get to that. Do you see it?
Yes.
Yeah. Do you have any idea how to find f of 3?
I do not.
Okay, no problem. Let's talk about it right now. So, you've got this x in parentheses right here after the f, right? You've got the x in parentheses. So if you see, whatever's in the parentheses is sort of your input in the function for f. Or for x, sorry, for x. So basically what that means is where there was an x, now there's a 3.
3, yep.
So all you're doing is just plugging in a 3 for x into the function.
Okay.
So you could rewrite that f of 3 equals 2, not times x, but 2 times 3 plus 1. Does that make some sense?
Yes.
Okay. Again, where there was an x, now there's a 3. By the way, what is f of 3 equal?
3 would be...
What's 2 times 3?
2 times 3. Oh, my gosh. I was thinking of f times... Okay, so which would be 6 plus 1, which is 7.
The 7. Yeah, there you go. F of 3 equals 7. Does that make some sense?
Yes. Okay. So with functions, is it when it's x like that, do you always plug in a 3?
Well, I'm just giving you an example. It could be anything, right? I mean, in this case, in the function of the question, we're plugging in a 1 for x. We'll get to that in just a minute, right? It could be anything. In most cases, it could be anything. Okay. Let's do some more functions. Let's find, so we'll use the same function, but let's find f of 4. Okay. What does f of 4 equal for the function up here that I wrote? What does f of 4 equal?
Okay. Which would be 2 times 6 plus 1, right? I mean, 2 times 4.
2 times 4, right? Yeah, we're plugging in the 4 for x. We get 2 times 4 plus 1. So what does f of 4 equal?
Which would be 7. Oh my gosh.
You got it. You got it.
9.
It's 9. You got it. Absolutely. Absolutely. So f of 4 equals 9. Okay. There's a couple ways to think about what this means here, right? You could say, okay, so when 4 is your input into the function, 9 is your output in the function.
Okay.
Okay. I really like thinking about functions in terms of inputs and outputs. Okay. I think it's the best way to think about it. Easiest way to think about it. Okay. Another way to think about it too, you could we know when x is 4, our output is 9. F of x, I coach students this all the time. F of x is really just fancy y. It's just fancy y. So, like, if you're graphing this function, f of x equals 2x plus 1, if you're graphing this on an xy axis, it would graph the exact same way as y equals 2x plus 1. It graphs the exact same way. Okay? So, you could say when x is 4, your y value is 9 on this function. And so it would graph as sort of this ordered pair, x comma y. You've seen ordered pairs before, right? Especially when you're graphing the xy axis. That would be a point on the graph of that function, 4 comma 9, right? Or remember when x was 3, what was our f of x value was 7, right? So the graph or the point 3 comma 7 is also on the graph of that function. Does that make some sense? You can say no, it doesn't.
Nope, it does.
Okay, good. I want to go to the rules real quick because I've got a section on functions here in the rules.
Okay.
Let's see, what basic concept is this? It is function. There you go, basic concept C. I want you to go and read that for me. Basic concept C is in cat. Read that bullet point for us, please.
Yep. Functions. Understand x is the input and f of x is correct. Is that right?
Correct.
Is the output. Also understand f of x as fancy y. They're interchangeable. They are interchangeable when graphing on a xy axis.
Yeah, f of x and y are totally interchangeable when you're graphing them on the xy axis. Does that make some sense?
I think so.
Okay. I think you've got enough of a handle on it right now for us, certainly for us to solve this question here. We're going to see some more functions questions coming up. So don't feel like you have to have perfect understanding right now. Just know that basically whatever's in parentheses, you're plugging in for x. That's the main takeaway for right now. Does that make sense?
I think so.
Okay. Let's practice it. We're going to find out. We're going to find out right now.
Yep.
So let's go to the function in the question. And remember, they're asking us here for f of 1. What is f of 1? Okay. And they give us the function. So how can we find f of 1?
Don't you just plug in 1?
Just plug in 1 for x into the function. That's it. Let me see you do it.
All right. So, sorry, I'm not on draw. My bad.
You're good.
Okay. So it would be, oh my gosh, the computer's glitching. F. 1.
Perfect. Yeah, f of 1. Perfect.
Okay. Do I keep going?
Keep going. Yeah.
Do you want me to finish the problem? Of course you want me to finish.
No, we're good. Okay, now you wrote 3 times x.
Right? Yep, I should have put a 1 right there. Hold
exactly, right? We're plugging into 1. 1 is our input into the function.
Sorry.
You got it. I can tell what's going on there. We got parentheses there. Okay, good. Yeah, so f of 1 equals 3 times 1 plus 7, and then that's in parentheses being squared. Good. We can simplify that a little bit.
Yes, we can.
You know how to simplify that?
So f times 1 would be
well,
f.
Remember, it's not f times 1.
F of 1.
Yeah.
Okay. So can we do anything with that or no?
No, we'll just leave it as f of 1 right now.
Okay, so then we can simplify 3 times 1, right?
Yeah, 3 times. Yeah, what's 3 times 1? Absolutely.
3. And then plus 7 would be 10.
Plus 7 is, it's 10. So I'll continue simplifying this here.
10. Second power.
Yeah.
Which would be 100.
Which is 100. There you go. Beautiful. I love what you did here where you kind of simplified the stuff in the parentheses first.
Yes.
That's the best way to do it. Some students get to this point right here and they're like, oh, I think I need to distribute that too. You know what I'm saying? And it's like, no, that's not what it means.
No, simplify.
Yeah. Simplify the stuff in parentheses first. We'll probably be talking about PEMDAS a little bit kind of as we work our way through the series. Are you familiar with PEMDAS?
I am not.
Okay. It's an acronym. It stands for parentheses, exponents, multiplication, division, addition, subtraction. It's order of operations. Yeah.
Oh, okay.
I'm going to add that to the cheat sheet, and we'll discuss that probably at a later point here. But But for right now, I just want you to understand that it's generally easier if you just simplify what's in parentheses like you did first before you do anything fancy.
Yes. Okay.
And but that gives you 100. You see the right answer here?
Yes. So we said 100.
100, answer choice E. There you go. Any questions about that?
No, sir. I don't think so.
Okay, good. But once again, it's a good example of like, you just got to understand what things mean in math. That's the real work, is understanding what things mean. And then when you understand what things mean, what to do is much more obvious, right? Okay, f of 1, I'm just plugging in a 1 for x. That's all it means. 1 is my input into the function. So replace the x with a 1, and you find the right answer. Okay. All right. And we'll see some more functions coming up for sure. They definitely test on it on the ACT. All right. Let's put another question up. Go ahead and read question number 6 for us, please, Abby.
You pronounce that Jorge, right?
Yeah, but you can just say Jay if you want. But yeah, it's Jorge, I think.
I'll just say Jorge's currently hourly wage for working at Denti Smiles is $12. Jorge was told that at the beginning of next month, his new hourly wage will be an increase of 6% of his current hourly wage. What will be Jorge's new hourly wage?
Ooh.
Okay. So
what do we solve here, Abby? Yeah.
You are solving for his new hourly wage.
His new hourly wage, absolutely, right? That last sentence of the question is always the thing that you're solving for. And his new wage, Abby, is an increase of 6% of his current wage.
So,
okay.
Do
you know how percents work? I mean, would you feel comfortable finding
I think
his new wage after it's increased by 6%? Do you know how to do that?
Can we go through it together?
Yeah, let's do it. We're absolutely going to do it together. Absolutely. Before we even do the math thing, though, we're going to talk about that in just a moment. Let's step back and let's just use that logic and common sense that we kind of talked about for my second rule, right? I mean, so we're talking about a 6% increase. Is that a big increase or not a very big increase?
I would say no. Yes, no.
Well, I don't know. Yeah, I mean, 6% increase. I'm trying to think about something that increases by 6%. I actually, so I'm in Texas. I think sales tax in Texas is like 6% or 8%. I'm not even sure. I should really know that. Boy, I've bought things before.
So,
but it's not a huge. Yeah, it's not crazy, right? It's not like 20% or 50% increase would be massive.
No.
You know what I'm saying? Like it's an increase, but it's not a crazy big increase.
Yeah.
You know what I'm saying?
So kind of. Yeah, mediocre kind of.
Yeah, I mean it's going up, but not by a crazy amount.
Pretty basic.
Yeah. So like, just looking at the answer choices, I think we can get rid of a couple answer choices that we know are just like too big of an increase. Once you realize that 6% isn't a huge increase.
Yes.
What two answer choices can we get rid of right off the bat?
I would say J and K.
Absolutely, right. And so I mean, look, this is if you don't know how to solve a question, and you may not know how to solve. Let me phrase it. You're definitely not going to know how to solve all of them. You can step back and use some logic and common sense. At the very least, you can eliminate some obviously incorrect answer choices. And if all you're doing at this point is just guessing, then you've got a much better chance of guessing right. Right now, we've got we talk about probability. You've got a 1 out of 3 probability of just guessing right.
Instead of 1 out of 5.
Instead of 1 out of 5. Absolutely right. Bringing it all together here, Abby. We're bringing it all together. So, okay, good. I think there's another answer choice we can get rid of that I know just doesn't make sense, that I know is not a 6% increase.
Okay.
And I know they're trying to trick you here with this answer choice. Do you see which answer choice I'm talking about here?
Are you saying F?
Yeah. Why are they trying to trick you with F?
Because that would just be adding
what?
Onto the...
Yeah. You're just adding 6 cents, but it's not a 6-cent increase. It's a 6% increase. That's just different.
Increase, yep.
So look what we've done here. We've got a 50-50 chance now.
Which is much easier.
Which is much better, right? I mean, that's a 50% chance. It's a 1 out of 2 chance. Much better probability than 1 out of 5. Much better. Sure. And we haven't even done a math thing.
Nope.
You starting to see how to approach these questions, Abby?
Yes.
This is the best way to think about this kind of test. It's just a weird game, And if you can increase your chances of guessing well, you're playing the game the right way, even if you don't know how to solve a thing. Okay?
Yep.
All right. let's talk about the math thing here, because I couldn't tell you like whether it's going to be answer choice G or H, like 1260 or 1272. Just looking at that, like they both seem reasonable, you know.
Yes.
Okay. First of all, let's talk about what percent means. Okay, we're dealing with 6% here. Do you know what 6% means?
6%. Well, means in what way?
Well, what percent the word percent means. Have you ever taken Latin, Abby?
Oh, I know this.
Have you taken
I couldn't
Latin?
tell you, but I do remember learning. I took a tiny bit of Latin.
Yeah.
2 years ago.
So if we're talking about like miles per hour, that just means
yes.
the number of miles divided by the number of hours.
Yes.
You know, per means out of or divided by. Okay.
Yes. Okay.
And then do you know what cent means? I'll bet you can figure this out.
No.
No? Here's a question for you. How many years are there in a century? How many years?
It's a century. So it would be per 100.
That's right? Exact. Yes, there's 100 years in a century. How many cents are there in a dollar?
100.
100, absolutely, right? So cent just means 100. It's Latin for 100. So 6% literally just means 6 per 100 or 6 divided by 100.
Per 100, yeah. Okay.
It's the same thing. Does that make sense?
Yes, sir.
Okay. Now we can express 6% as 6 divided by 100. We could also express that as a decimal. Just punch that in your calculator real quick. What's 6 divided by 100?
Okay, let me. Which would be 0.06.
0.06. 0.06 is 6%. It's the same. Just as it's 6 divided by 100. Those are all equivalent. Because percent means divided by 100. So if you see any percent, if you see like 12% of something, you know, just divide 12 by 100, you get 12%. It's 0.12. 50% is 50 divided by 100. It's 0.5 or 1/2.
Mm-hmm.
Does that make sense?
Yes, it does.
Okay, good. All right. So there's a couple ways to do this. If we want to find what the wage is now with this 6% increase, we can just find 6% of $12 and then add that onto 12, and that'll give us the new wage. Okay, let's start there by doing that. So multiply, you want to find the percent of something, just multiply 12 by 0.06. What does that give us?
Which would 0.72.
0.72. So that's the increase. It's a 72-cent increase. I think you see the right answer right now, right?
Yep. Which would be H.
Answer choice H, yeah, because it's going up by 72 cents. Another way you could do this, and I want to play with this because we're going to see this pop up a little bit more on the ACT, certainly a lot on the SAT as well. If you want to find a 6% increase, don't just, you can do it the 2 steps away. You find the 6% of 12 and then you add it to the original value, or you can multiply by 1.06. 1.06. Okay, now think about what this means here. Abby, first of all, what is 12 times 1?
It's just 12.
12. But we're not multiplying by 1 here, we're multiplying by 1.06. And 1.06 is literally 6% more than 1.
Yep.
So if you multiply 12 by 1.06, you'll get that 6% increase. Punch that in your calculator real quick. Tell me what you get when you multiply 12 by 1.06.
12.72.
12.72. You get the answer in one step.
Yep.
Does that make some sense?
Yes, sir.
Okay, good. And I really recommend knowing how to do it in that one-step way, because especially when we're talking about percent increase or percent decrease over time, you're going to need to be able to express it sort of in that form. If you got a percent increase, you got to be multiplying by something bigger than 1, right? In this case, 1.06 is bigger than 1. It's 6% more than 1. And if you're doing percent decrease, you got to be multiplying by something less than 1. We might see some more of those questions coming up a little bit later.
Okay.
But does this one make sense now?
Yes, it does.
Okay, good. But you had a really good shot of getting it just by guessing, when you should kind of think in logical, common sense terms as well. So.
Yeah.
All right.
Be a 50% chance instead of 20% chance.
Yeah, absolutely. All right. We got another question up here. Go and read question number 7 for us, please, when you see that on the screen.
Okay. The first term is 1 in the geometric sequence. 1, -3, 9, -27. What is the 7th term of the geometric sequence?
Ooh, okay. I'm guessing you don't know what that term means, geometric sequence. I'm guessing. Is that fair?
Geometric. I do not.
Yeah, no problem. I've got it here on the rules. Let's go to it real quick. I think I've got a section on sequences. Let me see here. There we go. Basic concept E as an elephant.
Yep.
Okay.
Found it.
And I've got two types of sequences here you might see on the ACT here. Start with the geometric sequence that we've got here on the question. What is that? What's a geometric sequence?
Geometric sequence is you're multiplying by the same number.
Yeah. Yeah. So all the terms in the set you're multiplying by some number sort of consecutively in order.
Mm-hmm.
Go ahead and read arithmetic sequence because we might see that as well at some point.
You are adding or subtracting by the same number.
Yeah. So be aware of these terms, what they mean. If it's an arithmetic sequence, you're adding or subtracting by the same number. With a geometric sequence, you are multiplying by the same number. Okay, so let's go back to the question here. So we've got these numbers sort of in this sequence, and consecutively, we're multiplying all of these terms here by the same number. We're starting with 1, right? It's the first term in the sequence.
Mm-hmm.
So we're multiplying that by some number that gives us -3.
Yes.
And then we multiply -3 by that same number, and it gives us 9.
Mm-hmm.
And then we multiply 9 by that same number, and we get -27. Do you have any idea what that number is that we're multiplying all these terms by?
-3.
-3, right? You just know it logically. I mean, you could set up an equation if you wanted to. It's like 1 times some number equals -3. You could do that. Divide both sides by -1. You get x equals -3. Or you could just kind of look at it logically like you did and be like, oh, clearly I'm multiplying by -3. And we could confirm that, right? Because okay, so when we're going from -3 to 9, are we multiplying by -3?
Mm-hmm.
Yeah, we are.
Yes.
Yeah.
Yes. We are.
Yeah. When we're going from 9 to -27, are we multiplying by -3?
Yes.
Heck yeah, we are. Okay. All right. So we know the first 4 terms, right? I'm going to list these out here. We've got 1, -3, 9, -27. We can figure out the 5th term in the sequence. What's the 5th term in the sequence?
81.
Yeah, positive 81 because we're multiplying by -3 there.
Yep.
What's the 6th term in the sequence?
-243.
Yeah. You're quick on that calculator. That looks good to me. And what's the 7th term in the sequence?
Positive 729.
What's the right answer here?
Is that right?
Yeah.
Which would be E.
Answer choice E. Bingo. Any questions about that?
I don't think so.
Okay,
Nope.
good. But you see the key there, once again, is understanding what things mean.
Yep. So
In the
like
question.
geometric sequence.
Yeah.
Gotta know.
Yeah, you just got to know what
Because
that
that's
means.
just saying multiplying something.
Exactly, right. And again, if it were an arithmetic sequence, that's tough to say. Arithmetic sequence, then we're adding or subtracting by the same number. In this case, we're multiplying. Okay.
Yeah, so it's only one answer. So
Yep.
you know.
Yep. All right. Great job, Abby.
Thank you.
You're welcome. Let's keep rolling. All right. Go ahead and read question number 8 for us, please, when you see it on your screen.
Okay, question number 8 is the shipping rate for customers of ShipQuick consists of a fee per box and a price per pound for each box. The table below gives you the fee and the price per pound for customers shipping boxes of various weights. And then Greg wants to ship. Greg wants ShipQuick to ship 1 box that weighs 15 pounds. What is the shipping rate for this box?
Okay. Ooh. What are we solving for here, Abby?
The shipping rate for the box.
Yeah, good, right? Again, this thing we're solving for is always at the end of the question.
At the end. Yep.
So we got to find the shipping rate for this box. Okay. Let's. It's not. I don't think it's obvious how to calculate that. Okay.
Mm-hmm.
I don't think it's obvious. Let's first start by just understanding this chart up here. Okay.
Okay.
Let's do that first. So let's start with sort of the y-axis going up and down. Okay. So notice that at the top it says the weight of the box in pounds, and then right here they tell us that less than 10 pounds, 20 to 25 pounds, then more than 25 pounds. Okay. Mm-hmm. And then the x-axis going left and right, we've got some other information. We've got a fee right here, and then the price per pound. Okay. Okay. Let's break down what this means. I'm going to start with the first part here. Okay.
Okay.
So we know that if the box is less than 10 pounds, what is the fee?
The fee is $5.
Fee is $5.
Per pound is $1.
Okay, good. So there's a fee and then some rate per pound as well. And then let's go to the next part here. right? If it's between 10 and 25 pounds, the fee.
It would be the fee was $10
Yeah.
per pound. It's 0.65.
Yeah. So it looks like the bigger the box, the price per pound is going down, but the fee's going up.
Yep.
Okay. All right. And then more than 25 pounds, big fee, right there.
It's $20.
$20,
Yep.
right? But the price per pound is 30 cents.
It is 30 cents.
Okay, great.
Yep.
Great. Well, Greg wants to ship a box that's 15 pounds. What's the shipping rate? How much is it going to cost him to ship this box?
Would that be the fee?
Well, the total cost, I think, is what they mean by shipping rate.
Oh, okay.
Yeah.
Okay, gotcha.
Yeah.
So we're solving for the total cost, correct?
The total cost, yeah. I wish they made it a little bit more clear, but that's what they mean by shipping rate. How much is it going to cost?
Okay, yeah, which is the total cost. I got it.
Right. And note, in case you weren't sure about what shipping rate means, look at the question again. Go to the beginning of the question.
Mm-hmm.
Do you see this?
For customers consists of a fee per box and a price. So it's both.
It's
so
both.
Which is the answer.
Yes, exactly. Does that make sense?
Yes, it does.
Okay. Where can we start here to find this the shipping rate for this box that's 15 pounds? Where can we start?
So if it's 15 pounds, they'll go to the weight of the box with the pounds, and then it would be through 10 through 25.
Exactly.
So you know it's on that.
It's at least $10. So we're starting with $10. Okay, good. Right off the bat, by the way, we can eliminate an answer choice.
Mm-hmm.
Which answer choice can we get rid of?
And hold on. Which would be under 10. So then answer F.
F is gone. Yeah. Okay.
Yep.
But I don't think we have to stop there. We can figure out what the price per pound is going to be. Well, we know what's the price per pound,
which would be 65 cents.
65 cents. So what's the cost going to be for this 15-pound box?
$10.65.
That's per pound, right?
Per pound.
And how many pounds do we have?
15. So it'd be 15 times.
There we go.
60, 6, 5, 15.
So what's 15 times 65 cents?
$9.75. Is that right?
I'm double checking here. That sounds right.
Okay.
Let me see. 65 times 15. Yeah, perfect. So $9.75. Okay, great. So what's the shipping rate?
Which would be $19.70.
There we go. That's it. Answer choice H. Any questions about that?
Oh, yep. There's the answer.
Yeah.
No questions.
Okay.
Good.
Beautiful.
All right.
Beautiful. Yeah, just adding those two up. But once again, it's like, I think you were getting a little bit stuck on what do they mean by shipping rate?
Mm-hmm.
Right? Well, they tell us.
Yep. You got
at the beginning. So
reread it.
But then also, study that chart a little bit, right, and kind of figure out what things mean in the chart. Oh, because we've got some like upfront fee, depending on the weight of the box, and then the price per pound. So you got to kind of add those two together. Calculate them separately, but add them together. You get the right answer. Any questions?
Yep. Nope.
Okay.
I think we're good.
Great. All right. All right. We've got another question up here on the screen. Go and read question number 9 for us, please.
All right. A computer chip is 0.32 centimeters thick, is made up of layers of silicone. If the top and bottom layers are each 0.03 centimeters thick, and the inner layer are each 0.02 centimeters thick, how many inner layers are there?
Woo-hoo-hoo.
Yeah. It's going to be fun.
Yeah. What are we solving for here, Abby?
Okay, we're solving for how many inner layers there are.
Yeah, how many inner layers there are in this computer chip. Okay, yikes.
Yeah.
Do you have any idea how to solve this? And you can say no if you don't.
Let's see. A computer chip is made of layers. I'm going to say no.
Okay. No problem.
Go through it. Yeah.
Let's start here, but let's start conceptualizing this the right way first. Okay, thinking about the right way. And I want to draw a picture. You might be like, but there's already a picture there. I'm like, yeah, but I want to zoom in a little bit.
Yeah, better picture.
Better picture. I want to zoom in a little bit at sort of like the thickness of this computer chip. So I'm going to draw sort of like a cross section of the computer chip right over here. Okay. And they tell us the top and bottom layers are 0.03 centimeters thick. And the inner layers are 0.02 centimeters thick. Okay, so the top and bottom layers are just a little bit thicker than the middle layers. Does that make some sense?
Yes.
Okay. And the whole thing is like 0.32 centimeters thick. So I'm just going to, and yeah, this is just like a rough estimate here, but like this top layer, it's going to be, it's not that big, but it's like 0.03. And then this bottom layer is also 0.03. And then some number of inner layers. They're going to be a little bit smaller, and we don't know that number, right? But some number. You know what I'm saying?
Yes.
And the question is, how many inner layers? Okay. Visual estimation might be kind of tricky here, but maybe there's a way to test the answer choices.
Yes, I think there is.
Right? You know, like solving it. There's a way to solve it. It's not too bad. Maybe some students watching this recording here are like, okay, I know exactly how to do it. Wonderful. There is a way to do it. It's not bad. But if you're unsure about how to proceed sort of with solving something, be like, okay, I don't know how to find the answer, but maybe I can test if A is correct. Maybe I can test if B is correct. Okay? Maybe I can test if C is correct. Let's start there. How could we test answer choice A?
Would it be just 13 multiplied by 0.03?
Well, the inner layers aren't 0.03.
Okay, so we're
how much are the inner layers?
Okay.
How much are the inner layers? They tell us.
Oh, 0. Okay, so the inner layers are 0.02.
Yeah, 0.02. Absolutely. So we can multiply 0.02 by 13, right?
Okay. Yes.
And then add that to these two outer layers and see if it gives us 0.32, which is what we're looking for ultimately. Does that make some sense?
I think so. Yes.
Let's test that real quick. So I'm going to multiply 0.02 by 13. I want you to do the same.
Okay.
What's that give us?
0.26.
0.26. And then we've got to add these two outer layers as well, right?
Mm-hmm.
So it's 0.03 plus 0.03.
Equals 0.32. 32.
Yeah. Yeah, that's right.
All right.
Give us 0.32. Any questions about that? I think that's...
No,
that we found it accidentally. And we're just going to do one more question for right now, and we'll take a little break before we go on to the next part.
Are we doing all math today? Is that right?
Yep.
All right.
All right, go and read question number 10 for us, please.
Okay. Question number 10 is, the table below shows the number of cars Jing sold each month last year. What is the median of the data in the table?
Well, here you go. We were just talking about median right at the beginning of the session today, right? Do you remember what median means?
The middle of something.
Yeah, the middle. Let's go back to it real quick. Make sure we've got that definition. We can go to the glossary. We can go to basic concept B. I think I've
middle
got
number.
both places. Yeah, it's the middle number, right? Now I've got to make this really clear. It's the middle number arranged from highest to lowest.
Arrange. Okay.
So you can't just be like, oh, I'll just pick the middle one. You know,
the middle number.
Yeah, right. Like, well, it's got to be from highest to lowest or lowest to highest, and then you're picking the middle number. So, okay. I mean, there's a couple ways to do this. I would probably honestly like make a list of these numbers. I mean, arrange them from lowest to highest. Let's start there, right? So what's the lowest number in the list? I'll just start listing these right below
Looks
the
like
question.
13.
Yeah, 13's the lowest.
13, and then 15, I think.
Yep, then 15. And I'm going to cross it, like once we've got those, I'm going to cross them out. So we got 13 gone, we got 15 gone.
16.
16 gone. What's next?
19?
19.
Yeah, there's two 19s.
Oh, there's two 19s. So we got to put 19 twice, though.
Yep.
Okay.
19.
Because I think we got 12 months, so we're going to need 12 values altogether.
22.
Okay.
And then we have two 25s as well.
Two 25s. Awesome.
And then 26, 27, 28, 29.
What are the others after 25? Oh, yeah. Oh, and those are nice.
26.
Yeah, 20. Beautiful, right? That's easy. 26, 27, 28,
20.
and 29. Okay, I'm going to pan over just a little bit. There we go. Okay, good. I think we've got all of them. Do we have all 12 values? Can you double check and make sure we've got 12 values? 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12. Yep. We've got 12.
12
on our list. Okay. Now here's the problem. A little bit of a problem here.
It's an even number.
It's an even number, yes. So we can't just pick. There's no middle exactly. So what you do if you see an even number in a median question, you need to take the mean or the classic average of the middle two numbers. The middle two numbers.
Oh, okay.
Yeah, yeah. So let's find the middle two numbers. Maybe you can just sort of look visually at this and find the middle two numbers. There's another way to do this. Have you seen this before? Maybe with median questions, like if you start crossing out the ones on the end, you can work your way to the middle. You know what I'm saying?
I actually have never done.
Yeah, yeah.
But
it works well in this. With a smaller set, it works. Let's practice that real quick. So I'm going to cross out the 2 on the outside. 13 and 20.
Oh, okay. Gone, I see. Right? I see what you're doing.
I'm going to do the 2 more on the outside. 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 Great. And I'm left with the middle two numbers.
Which is 22 and 25.
22 and 25. Does that make sense?
Yep.
Okay, good. Another way to do it, too, is if you've got like 12 numbers, you should realize that the middle, numbers basically 6 and 7 are going to be your middle two terms on an even set of numbers. And that's the case here. 22 is value number 6 and 25 is value number 7. I like that crossing out method. It's hard to mess up if you have a small set of numbers. If you've got like 300 numbers in a set, it's a little bit different. Crossing out, I don't recommend it. I don't recommend even listing them, but you can figure it out. Okay. So we just got to find the mean of those two. What's the mean of 22 and 25? I don't even think we need to calculate it. Look at the answer choices.
So it would be 22 plus... Oh, wait. Is it...
Look at look at the answer choices.
Divided by... Which would be... Oh, okay. Well, I got the wrong number, so I guess I'm doing it wrong.
Look. We know the right answer has to be between 25
and 22. Okay.
Right? So what's the right answer?
K,
it's got to be K, right? Let's step back for a minute and think about that. Like, you were struggling to calculate the mean, or maybe you didn't even know what to do with those two numbers, but just logically, you're like, okay, the answer's got to be between 22 and 25, and it is. And there's only one answer choice between 22 and 25.
Which is the answer. So that makes sense.
Yeah. But let's talk about calculating that real quick. How should you calculate the mean of 22 and 25? How do we find the mean?
Do you add and then...
Yeah, it's 22
divide?
plus 25. And then you divide by the number of values, and we've got 2 values there, right? You're not dividing by 12, right? We're finding the average of just those 2 numbers. So what's 22 plus 25?
Is, 47.
47. And what's 47 divided by 2?
23.5.
23.5. Answer choice K. Any questions about that?
No, sir.
Okay. Classic mistake a lot of students make on a question like this. Like, I'll just find the middle one in the set. And it's like, 13 kind of looks like it's in the middle. Answer choice F. Like, no.
That's wrong.
No, that's like the smallest number. Don't pick the smallest if we're talking about median. You've got to think about it in terms of arrange them in highest to lowest.
Okay.
Any questions about that?
No, sir.
Okay. Let's take a little break. We're going to wrap it up there, and we'll continue with some more of these questions here in part 2. Be on the lookout for that. For those of you watching the recording, if you have any questions, please just leave a question in the comment or leave a comment in the comment section. If there's a particular question you want to see, feel free to reach out to me, or I'll be happy to explain, maybe even make a little video for you. But thanks so much, guys, for watching, and look out for part 2.